So in this video, I'll be covering an example of a proof by contraposition. And so here's the example question, and it is proof for all integers if x squared is even, then x is even. And in this case, it's easier for us to say something about x than it is x squared, because we know that even integers can be written in the form of 2k, where k is an integer. This is much easier to work with than if we had x squared equals 2k, because then we'd end up with x equals square root of 2k, which would be hard to prove anything with. So in order to make this statement easier to work with, what we're going to do is take the contrapositive of this statement, and if we do that, this part is our p, this is our q. So we have if p then q. So the contrapositive is going to be not q implies not p. So our first step of the proof will be writing out the contrapositive. So we will prove the contrapositive. That would be integers if x is not even, then x squared is not even. And because they're integers in this case, we can replace not even with odd. So we will just write this as odd instead. So now that we have our contrapositive statement, we're going to let x be an arbitrary integer. So that deals with the for all portion. Then we're going to assume the if, as we normally would. So if x is odd, so we're going to assume that x is odd. That x is odd. And we're going to use that to show that x squared is odd. So if x is odd, we can write x as 2k plus 1, where k is an integer. And then we can solve for x squared by substituting in 2k plus 1. And so this is going to get us 4k squared plus 4k plus 1. And once we have this, we can go ahead and factor out a 2. And we're left with 2k squared plus 2k plus 1. Now, since we know that k is an integer, we know that 2k squared plus 2k is also an integer. So we can write that. So since k and since now we know that this is an integer, we have written x squared in the form of 2k plus 1, where this is now your new integer. So then we can say that thus x squared is odd. And that concludes our proof.